Okay, we are going to be talking about rationalizing denominators, and we will go back to our complex numbers and talk about how we can divide those now. So, starting out with, we are going to work to rationalize denominators. Why do we need to rationalize denominators? Well, back in the day when calculators were not as fancy as they are now, due to the order of operations of us needing to be able to multiply this 3 times 7, or 3 times square root of 7 for 4. Wow, I'm sorry, guys. Order of operations. We should have 4 divided by 3 times the square root of 7. Now, in the old calculators, in order to be able to do this before we had the order of operations function, you would have to take 3 times the square root of 7, which is fine. The calculator would spit out your 8 digits of whatever irrational number that was. Now, for the state of accuracy, those 8 digits were just a rounded number. So, in order to eliminate having to use rounding when they did these, they came up with a way to get off or get the square root off the bottom and end up putting the square root up top. So, this ends up becoming 4 um, square roots of 7 over 21. Now they could put in the calculator 4 times the square root of 7, and then immediately after that hit divided by 21 without ever having to require that the calculator use any rounding that the humans would have. So basically, the whole reason that this rationalizing the denominator came about was it came about to eliminate the need to have to use rounding so that your stats could be more accurate. So, basic rule for what we're doing today: you cannot have a square root on the bottom of a fraction. So down here, we see the square root of 7 on the bottom. We cannot have a square root on the bottom of a fraction. We are going to have to rationalize. Now, we need to get the square root off of the bottom. So how do we do that? Well, we have to do it by, not changing what is on the bottom. Okay? We have to do it without changing the fraction in general. So we're going to start out with that square root of 7 there. That's the issue. I need to get rid of that. So what I can do is I can multiply by a square root of 7 on the bottom. Because then what I'm going to end up having on the bottom is 3 square roots of 49. And I know that the square root of 49 is 7. So it essentially eliminates that square root on the bottom. So whatever your radical is on the bottom, that's what you are going to multiply by. Okay, you're going to multiply by whatever that radical is. Now, we cannot change the fraction. So I want to multiply this by 1, because if I multiply by 1, it's not going to change the fraction at all. So how do I make a number that is 1 with a denominator of square root of 7? Well, I have to do the same thing on the top. Square root of 7 divided by square root of 7 is just 1. So it's as if I have multiplied this fraction by 1. So I now have 4 square root of 7 on top, because 4 is on the outside, square root of 7 is on the inside. So you don't multiply them together, they're just stuck there. Over 3 square root of 49. Because multiply the outside numbers times each other. So 3, and then there's technically a 1 on the outside. 3 times 1 is 3. Multiply the inside numbers times each other. 7 times 7 gives me 49. Now, going about simplifying this, 49 breaks up into 7 and 7, so we can pull that pair out. So this ends up becoming 4 square roots of 7 over 3 times 7. I finish simplifying. 4 square roots of 7 over 21. And that is my answer. And that's all I do. So when this is called a monomial, basically there's just one term on the bottom. All you have to do is multiply by whatever that radical is, and then that allows you to isolate or to get the radical to the top. It allows you to rationalize the denominator. We're going to go through one more practice when we are dealing with a monomial. I've got 2 over the square root of 12. Okay, there are a couple different ways that you guys can do this, one of which I just need to multiply by whatever radical is on the bottom to get rid of it. So I do the same on the top and on the bottom. That gives me 2 square roots of 12 over a square root of 144. Okay, now, square root of 144 is just 12. I can break down the square root of 12, though. That could be 2 and 6. and then the 6 is 2 and 3. So there is a pair of 2's that would come to the outside. So I still have that 2 on the outside, times the pair of 2's that I just pulled out, square root of 3. So when I do that, I end up with 4 square root of 3 over 12. Can I simplify any more? Yeah, 4 over 12. Divide 4 by 12, that gives me 3. So I end up with my final answer of square root of 3 over 3. So that's one way that I can do that there. Another option that I've had kids do, I'll do this one in green, they break down from the beginning. So square root of 12 is 2 and 6, 2 and 3. So they have that pair of 2's they can pull out at the beginning. They make that 2 square roots of 3 because I pulled those 2's out. Then you can cancel your 2's and you're left with 1 over the square root of 3. Now, still not finished because we cannot have a square root on the bottom. Multiply top and bottom by whatever that radical is. When I do that, that ends up giving me a square root of 3 over a square root of 9. Top is just square root of 3. Square root of 9 itself is just 3. So that's your answer. So 2 different ways where you can go about getting the same answer. Basically, what you guys need to know from this first video is if there is a radical on the bottom, we multiply by that radical to get rid of it.